Does this thing even work? Whatever, get out of here. Anyways, what's up guys, girls, and list makers? I've always been very neutral about the demon list. On one hand, it's a super neat part of community history, especially since it features a time machine to view historical list placements, and it really shows how we as a community have gotten so much better at Geometry Dash since 2017. But on the other hand, every single time a level is placed, there's usually some form of controversy. Now, for a guy like me, in 2022, the prospect of gracing the demon list seemed nigh impossible. Geometry Dash is just too hard if I'm being completely for real. The amount of skill needed to beat one of the top 150 levels is just unreal, and there's a lot of people who possess that skill, since the issue is half difficulty and half time. I have this issue where it takes me a really long time to beat hard levels because I devote a lot of my time to making videos, which leaves me less time to grind at extremes, which means by the time I beat a level, it's fallen about 75 positions on the list. So one day, I decided to remedy that. If I can't beat a top 150 on the Pointer Crate demon list, what if I made my own version of the demon list that only contains levels that me and my friends have beaten? Well, the answer is that I still can't even beat a top 10 because one of my friends is way better than me. Anyways, yeah, this is going to be a bit of a different video, similar to Colin's video from like 5 years ago, where he talks about how he made GD Browser. So strap in and prepare to learn about various computer science topics from a guy who figured out half of them while making this project, because today I'm going to explain to you how I created the ledge list. Please don't click off, I promise I'll make it interesting. Oh, also, it's called the ledge list because of an inside joke regarding this image. I'm not going to explain it any further. Before we continue though, I just want to remind you to hit the subscribe button, baby! Yeah! Because they've almost 300k, and now we're setting our sights on 400k. Let's go! Alright, back to listing. First things first. This entire demon list is what we in the business call a full stack project, which means that I alone created the entire front end, which is everything the user sees, aka the website, and the back end, which is the database, API, and depending on how you view it, the Discord bot that I use it through. The first and most important thing we need to talk about is the database. You probably know what a database is. It's the collection of all the data that we're going to be putting on the website later on down the line. Essentially, a database in this context is just a couple of tables where each column is a different piece of data, like a level name, a date, or a level ID. These pieces of information are called keys. Each table in a database requires one column to be the primary key, which is a completely unique piece of information that you can rely on to distinguish between entries. Say we have a table of levels, and in that table we keep track of the level ID, level name, creator, and length. In this instance, we choose the level ID to be the primary key since we can guarantee it'll always be unique. Geometry Dash doesn't let levels have the same ID after all. The level name isn't guaranteed to be unique since multiple creators can upload levels with the same name. The creator isn't going to be unique since one creator can upload multiple levels. And the length isn't going to be unique for obvious reasons. The other important type of key is a foreign key. A foreign key is a column in one table that creates a link to the primary key of another table. This connection lets the database keep track of how data in one table relates to data in another. I'm not going to go super deep into it because that'd make everybody click off the video, but the TLDR is that if I use the foreign key in a table that relates to another table's primary key, it prevents me from doing something like adding a record on a level that isn't on the list. If the level ID isn't in the levels table, then I can't add a record for it in the records table, since the level ID in the records table is a foreign key tied to the level ID in the levels table. Also, you can model any database schema into a diagram, but I kinda hated doing these in school, so we're gonna gloss over it, but this is what the diagram for my demon list looks like. Now that we have the basics of relational databases under our belt, it's time to actually create the thing, which means using our first programming language of the video, SQL, or SQL, I guess, but my professors in school discouraged pronouncing it like that. SQL is actually one of the easiest programming languages I've ever learned. I picked it up in an intermediate level in like an afternoon. Its syntax is vaguely reminiscent of regular English, so that makes it pretty easy to work with. I won't bore you with the details of how everything in it works, but let's run through the first thing I did, creating the levels table. Levels are the backbone of the demon list, so naturally I need to get all the levels logged before I can start adding records to them. The command looks like this. Simply put, if the levels table doesn't already exist, create it. It will have the following columns. Level ID, which is the primary key and is an integer, you know, a whole number. A level name, which can be any string with a max length of 35 characters. Note, I chose this number completely arbitrarily. Geometry level names are limited to 20 characters anyway, but I didn't bother to check that, so I just picked some larger number. Also, you may have noticed the not null at the end of every line. That just means these values can't be blank. We need them all filled in. If we had any optional data, like a verification video or something, then we wouldn't put not null there. Anyways, moving along, we have a level creator that's also a string of up to 35 characters, a level position that is another integer, and a points value, which is a decimal that can store up to 6 characters with 2 digits shown after the decimal point, which basically means it can store up to any 4-digit number, since anything higher would be 7 digits. And this value defaults to 0. I have a function that automatically calculates the points, but I won't get into that. Anyways, now we have a database that has all of our data, but we want to make this easier to use. I don't want to have to open up an SQL program and log in every single time we have to add a new level or record to the list. Enter Le Discord bot. I believe sites like PointerCrate and the all-rated Extreme Demon List use a staff-only portal of their website to add levels and records, but that would require more cybersecurity knowledge than I have. So I decided to just create a Discord bot that I can control access to with a single role. If you don't have the Discord role, you can't do any data modification on the database. There's a couple of ways to write a Discord bot, but I chose Python, since Python is also very English adjacent, making it very easy to work with. Python is infamous for being pretty slow as a programming language, but frankly, I'm not going to lose sleep over having to wait half a second for my commands to go through. If anything, the bottleneck here is the speed of Discord. The main functions of the Discord bot are to take data from the database and display it in a nicer format in a Discord channel, or take data from the user and put it in the database. This is nice because it prevents what is known as SQL injection. SQL injection is essentially a security problem where if you let a user type in any value to fill in part of an SQL statement, they could type in an unintended value and get more data than they otherwise should. This isn't really that big of a deal since only me and my friends are using this, but it's still good practice to prevent anyone from accidentally entering bad data. Again, I won't go through every single command the bot has since there's a lot of them, but let's step through a basic one, outputting every level on the list. First, I have a function that looks like this. First, we connect to the database by logging in, then we perform this SQL query. If we did this in the SQL program, we'd get a big table that looks like this, but since we don't have tables here, it just outputs as a big array of data. We create an empty list of levels and pages, and step through each level that was returned, format it properly, just like bolding the level position, underlining the name, stuff like that. And then we add that formatted string to the levels list. When we reach this point, the levels list contains every formatted level string, and now we have to split them up into pages. We run through every level in this level list, increasing an index number each time. When that number hits 9, we know that this is the 10th level so far, since we started counting at 0. Since we want 10 levels per page, this is the end of the first page. So we add these 10 levels to the page list, reset the index to 0, and continue. By the time we're done with the levels list, the page list contains a grouping of every 10 levels. We return this, set the default page to the first one, and boom! We have an interactive list of every page of levels. A more complicated version of this kind of thing is how I made commands that let me put data on the database. The only difference is the Discord command takes in parameters from the user, and instead of selecting from the table, we're now inserting into it instead. Alright, so now we have a database and a way for one Discord server to interface with it. But I want to share this project with the world, so we need a website. The question is, how do we get the information from the database onto a website? While it is possible, I think, to have a website that directly connects to a database and gets information from it, that's probably a security risk since you'd have to put the login credentials for the database in the code for your website, so we need a middleman. In comes the API. You might have also heard of APIs. API stands for Application Programming Interface, but that's not important knowledge here. Basically, the API's job is to talk to the database, take its output, mush it into something more readable for a web browser, and serve it up. Most APIs return JSON, which is a structured data format, and it is very nice to iterate through. APIs also have what are called endpoints, which are basically the locations we can visit on the API to get the data. In order to set this up, we use a Python library called Flask. Flask is a framework that lets us build real simple back-end web applications. And remember, back-end stuff is all the stuff the user doesn't directly interface with. Here's some template code for an incredibly basic Flask API. Say we're hosting this on NicoOneShot.com. In this instance, if you go to your web browser and visit NicoOneShot.com, you'll see the text "Hello World" on a white background. This is not JSON. However, if we visit NicoOneShot.com/test, we will get some JSON with the message "This is a test endpoint" and the status "Success." You can tell that it's JSON because it's formatted differently, and your web browser will display it as such. We could, in theory, parse this JSON to extract only the message or status from it. In the case of the daemon list, we have to connect to the database and retrieve information to display first. So when you visit the endpoint /levels, we connect to the database, get a list of all the levels, then take the gross unreadable arrays the database gives by default, and in a similar way that we did with the Discord bot, modify the data. Except this time, instead of turning it into a Discord message string with formatting, we're turning it into JSON. Once we're done, we return the full thing, and voila! We have an API. APIs are incredibly easy to implement into a web project. I used React for the website, which is a JavaScript framework, and to make a long story short, essentially it's just making like 5 requests to the API when you load the page to get every level, player, every level each player is completed, and some other stuff. When you click on a level, it makes a request to get all records for that level and randomly picks one of the videos to display. The video that was chosen is bolded, so if you only want to see my videos, just click on the level name until you get my video displayed. It randomly picks every single time you click it. The requests basically all look like this. Basically, this block of code runs once when the page loads, and this line is the core of it all. Levels API is just a link to the /levels part of the API. First, it sets a loading flag to be true. This lets me display a loading message on screen as long as it's true. As soon as this flag becomes false, the loading message goes away. It tries to get the JSON from the API up to 3 times in case it fails, and waits 180 milliseconds between each try. If it fails 3 times, it just gives up and displays the failed to load levels text. If it succeeds, it stores the result in a state named levels that we can iterate through later. Whether or not it fails or succeeds, after it all, we set the loading flag to false. This is how everything that interfaces with my database works, but you may have noticed one extra detail: the position on the all rated list. How did I get that there? Well, since we have the information about each level from the call to my API, we can take the list of all the level IDs from my list and find them in the all rated lists level list. The all-rated list has an endpoint that just returns every single level's information, so we find the right levels and grab their positions, and now we're done. That's all it takes to make your own daemon list. I know it might seem like a lot of work for what is essentially only a tool that me and my friends will use, but to be fair, I'm not the first person to come up with this idea anyways. I think I've just gone the furthest with actual implementation. You can find the site by going to sdslayer.com/list or just sdslayer.com and clicking the button on the main page. I plan to add more features like a players page where you can see each player's levels ordered by difficulty or most recent. I'm sure that in all honesty, a lot of people are only going to use it to see my extreme completions because, like, you guys haven't heard of my friends. And that's fine. Maybe this will finally be how people realize I'm not complete trash at Geometry Dash and have actually beaten some pretty hard levels. But yeah, anyways, thanks for watching. I hope you enjoyed. It's a very different kind of video, and I'll probably not be making one like this again, but yeah, I had fun making it. Special thanks to all channel members including Gatto, Gabriel555Ty, Ghosty, Artificial, Cool Dude XD, Neo, Brickster, and Marvinbox. And yeah, I'll see you guys all in the next video with your regularly scheduled garbage.